Okay, so factoring, super useful. We will use this all year, and I'm not kidding, all year. I will say you need to factor all year. This quarter, next quarter, the last quarter, all of them. You need to factor. So we need to know what factoring is, and it's quite simple. Everyone in here has distributed before, right? Drawn your rainbows and multiplied, x times x times -1, 4 times x, right? Foiling, or maybe you've done distributing like this in your box. That's another method, same thing. Okay, we've all distributed. Factoring is just the opposite. It undoes the distributive property. So we would start with our quadratic. Factoring gets us back to the beginning of distributing. It's just the opposite. Factoring is how we undo distributing, and why it is so useful is that in math, polynomials, which a quadratic is a type of polynomial, the only way to solve them is by factoring. You can find solutions when it's factored. You cannot find solutions when it's unfactored. So that's why this skill is super useful, because we learn about polynomials all year, and factoring is the easiest way to solve them. Okay, we will be factoring using this method, the X method. There's a million ways to factor. I like this one. This is the one I usually teach. You may have learned it other ways. I learned it by guessing and checking, and it was a nightmare because this method wasn't invented then. So here we go. Example number 1. We have 6 steps to factoring. It looks like a lot. It's going to feel like a lot. Trust me, everyone in here is going to get so good at it. We need to factor 6x squared plus 15x minus 9 using this x method. Okay, I'm just going to rewrite my problem first. 6x squared plus 15x minus 9. Go away. Okay? The first step you always need to do, you always need to check for this. If you do not do it, you cannot factor. The first thing you will do is check and see, is there a greatest common factor? If there is, you need to divide it out. So here's our quadratic, 6x squared plus 15x minus 9. We need to figure out, is there a greatest common factor? That is why we spent yesterday doing this. What are the factors of 6? 1, 6, 2, 3. What are the factors of 15? 1, 15. 3, 5. And 9? 1, 9. And 3 and 3. Is there a greatest common factor?
3.
You bet. 3. 3 is the greatest common factor. There will be times when your quadratic does not have a greatest common factor, and you get to just skip this step. We have a greatest common factor, and now that we've found it, we now have to factor it out. We have to take it out. Okay? So we need to divide out a 3 from each term. So what is 6 divided by 3? 2. X squared comes along for the ride. 15 divided by 3 is 5 plus 5x. And 9 divided by 3 is 3. Bring down the minus 3. So we have taken out our greatest common factor. Now the GCF doesn't just disappear and go away. It's still a part of our problem. So we throw it out front. It's still there. It didn't just disappear. If you wanted to draw your rainbows and distribute the 3 through, it would go back to where it was. Okay, that is step 1. Go ahead and go up to the top and check off step 1. Done. It feels good to do it. Step number 2 is identifying your A, B, and C values. Okay? We are focusing on our new quadratic we have. Okay, we don't want the A, B, C value of the original. We took out the greatest common factor so we can write down A, B, and C. Okay, so what is my A, B, and C value? A is 2. B is, and C, -3. There's my A, my B, and my C. The whole purpose of the greatest common factor was so that we can find our A, B, and C, and now move on to step 3, which is filling out part of our X method. So everyone right now should draw their X. Doesn't have to be huge. Don't make it too small. And we start filling this out. If we look at the top, we have our X method right here, all spelled out for us. The top is A times the C value. So let's multiply. A times C is -6. Write it on top. On the bottom, we look at our little cheat sheet, is our B value. Our B value is 5. Write it on the bottom. Okay? That's step 3. Check it off. Step 1, 2, 3, done. Step number 4 is what we've been doing, what you just did at the beginning of class, and that is finding your mystery numbers. We need 2 numbers that multiply to give us the top and add to give us the bottom. Okay? Now 6 isn't a very big number. It doesn't have that many factors. Eventually you will get good enough at this where you can just do it right in your head. But we're going to just practice writing down our factors. So 6. What are the ways to make 6? We just did it over there. 1 and 6, 2 and 3. Now, these multiply are all positive, so they multiply to a positive 6, but they need to multiply to be -6. So either my small numbers I need to make negative, or my large numbers I need to make negative. Okay, you can tell by looking at the bottom. The bottom is positive, so does it make more sense to make the small numbers negative or the big numbers negative? Small numbers. If you make the smaller numbers negative, then when you add them together, they'll still be positive. Okay? So either -1, 6 is our answer, or -2 and 3 are our mystery numbers. There's only one way to find out. We add. What's -1 plus 6? 5. Does that work? That's the winner. Winner, winner. Chicken dinner. -1 plus 6 is 5. That's our winner. If we wanted to just check for funsies, -1 plus 3, or -2 plus 3 is 1. That does not work. So -1 and 6 are the mystery numbers. Those are our mystery numbers. Okay, step 4 done. Found the mystery numbers. Now we have to simplify this left and right side of the X method. Now what do I have to do to my mystery numbers? Divide it by 2, our A value. So we need to divide these sides by A, which is 2. Always, no matter what, you divide by your A value. And guess what? Why do you think we simplified fractions yesterday? Because guess what we need to do to those left and right sides? Simplify the fractions. You remember the buttons in your calculator? Math, enter, enter. So let's do it. -1 divided by 2, math, enter, enter. It's still -1/2. That's already simplified. That means -1/2 this is our p-value. Right side, 6 divided by 2. 3. That's our Q value. That's our Q value. Step 5, done. Simplified the left and right side. All we have left to do is write your factor in factored form. Now you don't have to have the factored form memorized, but what is super helpful, and I added, it is not in your packet, is this right here. When you write your factored form, you're going to need to flip the sign of P and Q. Okay, flip the sign of P and Q. I would add that somewhere. It is so important. You need to remember to flip them when you plug them in. Okay, so if we look at our little form, we always start with the GCF. So what is our GCF? 3 x. What is our p-value? -1/2, but we flip it and it becomes +1/2. Another x. Our q value looks like 3. When we plug it in, it will be -3, -3. Now this is almost perfect factored form. But we do not like yucky fractions. We do not like them. This is called the Schwoope method. It's fun to say, Schwoope. Because all you're going to do, like this example, x -1/2, we take the 2, and we Schwoope it in front of the x to become 2x - 1. It seems weird, like why are you allowed to do that? Really all we're doing is multiplying this by 2. So we're going to take this 2, and we are going to Schwoope it in front of the x, and our final answer is 3 times 2x plus 1 times x - 3. That is factored form, because once we get a lot of ink on the screen, it starts to get laggy. That is my original quadratic factored out. If you were to distribute all of this back together, you would get back to the original problem. Okay, this is factoring. From this form, you're able to solve this quadratic. If you can't factor, you can't solve. Question? Or should we just do another? Okay, can I move on? Popping it down. It was a lot of work, wasn't it?